So everyone, welcome to today's session of our Speakers Forge. It's going to be a really interesting session. Thank you so much for hanging out and spending your lunch with us. We're going to give it a minute or so just to have everyone log in and join. And if your friends are not here, remind them that they can still pop in and we'll bring them through. So today we're going to be chatting about a few things along the line specifically of Jeff's recently published article, and he'll be showing the presentation that he actually did for that article as well. And there are a couple of polls in the space as well if you guys want to engage. So we also have Evil, one of the most fun people that I've worked with in ages. He works as a freelance developer in all the interesting and fantastic languages that we don't always get to play with. So if you need some advice on Kotlin, he is your Kotlin guy, and pretty much everything else in between. So as always, the session is recorded. There will be a section for the chat. So if you've got questions, leave us a question. If you've got comments, feel free to message us in the comment section. We are here to answer any questions, and the session will be recorded. So if you have to drop off, I'll be sharing that on our YouTube channel as well. So I think let's give it a minute or so and we will get the ball rolling. All right. So for today, I think we're going to start off with Jeff. Jeff, would you mind screen sharing with us, and let's get the chat started.
Cool. Oh, there we go. Is it coming through? Awesome.
Good.
Okay. How do I get it to focus on me now? Just to speak, hey?
Yes, you can just speak.
Okay, great. So just a little bit about this presentation. So this was a paper co-authored with me and by myself and my supervisor at BITS, Dr. Stephen Levitt. The title of the paper that we presented at the SciCert conference is The Quality Impact of Accommodating Customer Requirements Through Plugins and Configuration Files. This actually came as a paper that we produced based on my MSc. Yeah, so I would like to share that with everyone today. Just a little bit of context and motivation. So this is within the context of software configuration and customization. So in the real world, systems are often customized to meet specific customer requirements. So what that means is you've got some kind of software and there is something tailored done for a specific customer. This is often some kind of ERP system or something like that. So within that context, some kind of configurable architecture aims to accommodate these kinds of variations, often using something like dependency injection, for example. In this particular case, we've got, and would often be the case in some kind of customization, you've got some kind of base software, and it's polymorphically extended to introduce the new behaviors for that specific customer. In this case, customization, we think of it as not really affecting the methodology, so the way in which software is built, but it can affect the quality of the software that comes out, since you are affecting the actual behaviors. So within that, we're sort of looking at software quality within that. So are software architectures that are configurable effective at achieving or at accommodating these customizations? Do we have the freedom to express the changes as software developers that we need? And the ultimate goal of the study in the paper was to expand the body of knowledge to inform build or buy decisions. So a little bit about the research questions. So the core research question had 3 parts. So all within the case of a system that is designed for configurability. When considering structural quality, we wanted to know how does the structural quality of the customizations compare to the rest of the system. When looking at our functional quality, we want to know what effect does the customization have on that functional quality, which is the quality as perceived by the user. And lastly, as mentioned in the previous slide, how effective is the architecture in supporting the changes required by different customers? So a couple of notes on the internal validity of the study. So those of you who are familiar with the formal academic study process, in this case, we are excluding developer skill as one of the variables. And the reason for that is that it's one team that has been working on this specific piece of software. And we are also excluding the process and analysis portion. So even if, for example, a defect originates within the analysis phase, it's not like that would be any different whether it was sort of part of the main development or if it was part of a customization. The main thing of interest as well is that we're looking at, does the process of doing these customizations itself impact the quality? So two little notes about the internal validity of the study there. Just a few notes on some of the previous and related work that we considered as part of this study. So there's quite a lot of literature, for example, on the feasibility of ERP extensions. Literature seems to indicate that you introduce significant risk to a project when the customization is beyond 30% of the size of the project or of the software. And very importantly, the software or the importance of alignment of the software to the business. So it's very important that the software is already well aligned to a specific business operation if you want to have your customization be feasible. There's also literature covering the maintenance implications for ERP systems. This includes things like classifying the different types of changes, so everything from the least impact being changing, adding a new report, for example, and the most impactful being changing actual things within the software itself. So everything in between that, if we were to add functionality, if we were to automate some of the processes or amend some of the reports. And obviously, functional quality is of very central interest to this particular study. So a lot of literature on functional quality normally focuses around things like how fit for purpose is the software. So things like GQM or goal question metrics provide a framework for gathering information on how well the software is working for a specific user. That is quite labor intensive and also relatively subjective. Even though it's structured, the structure aims to reduce that. But an alternative that we chose for this specific study was inferring the absence of quality through defect. So in other words, the absence of defect is an indication of quality, or the presence of defect is an indication of the absence of quality, because as experienced by the users, any defect obviously provides a poor quality of experience for a given user. This study took the form specifically of a case study. So some specific reasons for that is there is a shared common base. So in other words, we've got this central piece of software that will be common to all customers. And then there are varying degrees of changes applied to various customers. So in particular, we're talking about a customer that's very close to out the box. So very little customization, that the software is effectively very aligned to the specific customer. Then a customer that has been heavily configured. So this is where a lot of new things were introduced to accommodate this specific customer by way of configuration specifically. And then what we have referred to as domain modified. So this in particular refers to the actual core system itself was extended in some way to accommodate a specific requirement that actually didn't exist before and would not have been achievable through just the normal configuration or plugin interface. So in particular, this is an exploratory case study. So it's an investigation into the effect that customization has on software quality. The customers that are considered, they were curated. So in other words, as part of a case study, specific customers have been selected, and in this case, based on the perception from customers regarding the software. And most importantly, this is a realistic scenario. So we're talking about the real life use of a piece of software in its third revision with real customers in different industries over several years. Okay, so a little bit about what this application does. So specifically, it's a weighbridge application. The central concern of it is the way out of a shipment. So in this case, we've got some kind of scale at the scale of a truck. So a truck, when leaving some kind of plant or factory, would drive over this scale. You would weigh how heavy that vehicle is. You'd record that measurement. If there's some kind of problem, then like the truck is overweight, for example, you could prevent the dispatch of that truck. So stop the truck going onto the roads or leaving the plant. And you can also do things like maybe you want to operate the boom or print some kind of ticket, integrate to another system or something like that. Then the other end of the transaction is the weigh in. So now the truck has gone on its journey and it arrives at some specific destination, and we weigh the vehicle again, record that weight, and then we most importantly want to correlate that against the dispatch weight. So that would tell us, for example, if the truck was carrying coal or if it was carrying grain, it would give some indication as to if there's been any loss of the cargo in that case. So it can help reduce fraud in that case. And again, print tickets or operate booms or integrate to other systems, for example. So a little bit about the customers that were selected. So as mentioned, out the box, so this is very little configuration. So the operation is very closely aligned to the way the software has been built. Heavy customization, again, extensive configuration used to provide that functionality that this customer requires. And this was the key difference here, or the key verbiage here, is that configuration rather than writing code, for example. So all customers have this code running on their system, but this configuration there's a lot of configuration points for this specific customer to meet their needs. And then lastly, that domain modified. So there's a change to some kind of fundamental change to the process or to the way that the software works. In this case, it was for a road ordnance operator. So in this case, there's only a way out or a way in. In other words, there's not the two legs of that transaction. So that's interesting because it's quite a different process to the other customers. And in addition, another concern needed to be added in, and that is the addition of some kind of account facility. So if taxes needed to be levied against the truck or something, then you have something tying different shipments together. So that's a concept that didn't exist previously until this customer was accommodated. So we've got a piece of code, a very particular customization, very specific to that customer. I will go into a little bit more detail on the configuration in the next slide, how it works. But the kind of configurable components are things obviously like your branding and UI labels. Maybe there are custom processes that you want to define. So this screen, there you might want to enable or disable specific fields or introduce some kind of specific validation to that company. Maybe there's a custom behavior you want to introduce. So that could, for example, be an integration or operating the boom, for example. And we talk about built-in or core configurations, and then we talk about plugin configurations. So the core ones are effectively the ones that are native to the software, the ones that are part of that common base, if that makes sense. And then plugin configurations are the ones that are extended to specific customers. Right, so the configuration mechanism itself, it's a plugin-based architecture, taking advantage of dependency injection to obviously load plugins. It uses MVVM on the front end, so that obviously also provides some kind of substitutability. And the configurations themselves are stored in XML files that are defined for the customer. So one such example of a configuration file, so any point of configuration basically starts with what's called a rule context. So the more rule context you have, the more configuration there is for this customer. And if we've got the shipment screen, so this is just a sort of an abstract example of it. So a horse, for those of you who don't know, the cab section of a truck where the driver sits and you've got the engine, that's referred to as a horse because it pulls the truck. So we've got a field to capture the horse, the body, and some custom field that we want to use. So one of the very first things we look at is there may be certain things built into this view that we can turn on and off. So for example, I could say, don't allow the driver to go with an expired license. And maybe I want to turn off or turn on validations for this screen. Turn on or off this specific screen. Then inside the view, I want to maybe configure specific things. So maybe I'm not interested in capturing the horse information. So in that case, what I can do is basically set the enable to false, which will obviously now remove the horse from that view. Then I want to make sure that I can see the body. And then custom field, I don't want it to be called custom field anymore. I instead want it to be called permit, for example. So that's one other customization that we can do. Then there's different ways of validation. So this is where we're starting to customize some portion of the behaviors. So for example, I want to make sure that it's going to validate that the truck is within the legal weight limit. So that's a custom validation applied to the screen, but this is one that's built into the software as well. So every customer basically has that available to them. Then there's other behaviors I could introduce. So built into the software, for example, are things like maybe I want to stamp a shipment. So that means like I've got some kind of label or something, or I want to create some kind of ticket. So in other words, some kind of thing that I can print as well, perhaps. And then in this particular case, I'm customizing for Acme Corporation. And I want to do something on the complete shipment. So this would typically be things like integrating into an ERP system to say, hey, here's a shipment or something like that. And then lastly, once the save has been completed successfully, maybe there are other actions I want to do. So maybe I want to go and print the ticket here that I actually created previously. And that is, in a nutshell, basically how the application gets customized. So talking about some of the data sources that we used for this application as part of the studies, So the software team used Jira to track all the defects along the way. So that was a useful source of data. So we were able to allocate defects per customer. And that is obviously quite a central measurement since that is our measure of quality. Then we are extracting certain types of information from the configuration files themselves. So this includes things like how many rules do we have, how many rules are configured to use custom code, so it's not stuff that's built in, obviously, versus things that are unique to that specific customer. And obviously how many of these configurations have been customized. Then there are a whole bunch of metrics we can extract from C# source files, for example. So this is important from the perspective of structural quality. The central measurement that we actually take is something called the maintainability index. If any of you have used Visual Studio and you calculate code metrics, you'll see that maintainability index is one of the things that comes up. Other metrics that we are interested in are things like how many calls there are to other classes, what is the cyclomatic complexity. Cyclomatic complexity is simply described as how many, or the simplest way to describe it is how many if statements are there within a piece of code. We're also interested in things like how many methods there are, how much fan out there is, so in other words, how much coupling is there, and obviously the actual size of the code is a useful measure as well. So as mentioned before, the specific metrics that we're actually now dealing with as part of the study, we're looking at, first of all, the functional quality. So this is the quality as experienced by the user of the system. So as mentioned, we're measuring quality through the absence of quality. So more bugs, less quality. And this was done basically as the number of issues logged as bugs and counted as allocated per customer. As for our structural quality, so this is the quality that a developer might see. If you're going to do an audit or if you're busy working on the system, this would be what a developer might say the quality of the system is. So there we're interested in, like I said before, the lines of code, depth of inheritance, cyclomatic complexity, class coupling, maintainability index. The maintainability index is the main measurement that we're using. Inside the paper, we talk about why the other ones are important because, well, I'll go into that in a second. So maintainability index itself is based on a study done, I think, in the 80s and 90s, and it's supposed to be a predictor of how maintainable a piece of code is, and it's based on a regressive model. So the authors took a large number of projects and did an extensive study to figure out how easily maintainable the software is, and they produced a regression. Visual Studio, as I said, has a specific implementation of this, and it basically takes into account specifically the cyclomatic complexity, how much code there is, and something called a Halstead volume. Complicated, well, not too complicated, but the main thing is it talks about program length and vocabulary. So it's basically how many operators do you have in total and how many different operators do you have in a simple way. But one of the things that we needed to compensate for as part of the study is that there is generated code as part of this code base. So we want to exclude this because it's not developer code. Because it's produced by a machine, its quality will always be 100% consistent. So in this case, the generated code typically manages things like your create, read, update, and delete type code. We're able to detect which classes or which pieces of code are generated based on where the source file directory is. So when it had the name generated in, we excluded that. But now the problem is we needed to recalculate our maintainability index for at various different levels, excluding that generated code. So that basically involved all of the other measurements that we took and then extracting certain things out from that and recalculating the maintainability index. Also, application-specific metrics, I've mentioned this before, but basically this is all based on the configuration source. So it's how many rules do we have, the core and the plugin extensions, as well as sort of an average lines of code per assembly. So the main results of what we found is basically in this chart. So on the left here, we have basically that customer number 3, the domain modified. So they have a lot of lines of code specifically to that customer. And also they've got the fewest number of bugs, for example. We can also see that this maintainability index is relatively flat, which in this case suggests that, and this would be expected, that with the same team busy developing, that we're going to get a consistent level of quality, structural quality. So in other words, the craft of the developers is consistent basically across all the various different customers. But we can see that their quality as experienced through the bugs can vary. And interestingly enough, that this is increasing with the number of rules. So in other words, how much customization or how much configuration specifically has been defined for that specific customer. So what we are basically looking at is to say that in this, given this view, so if we take this out the box as a baseline, the customer quality was superior when we wrote code specifically for that customer instead of trying to accommodate those changes through some kind of configurable aspect. Whereas when we did that for a customer with heavy configurations and writing less code specific to that customer, their experience was basically poorer because they had more bugs. This then brings us to our conclusion that we find that the structural quality remains relatively unaffected as measured through the maintainability index. although it is noteworthy that all of the plugin code is marginally less maintainable. So this was caused, for example, by longer methods with more fan out. So the methods were a bit longer than other parts of the system and had a little bit more coupling. That is probably to be expected given that these plugins are usually to integrate to some other system as well. Functional quality, our finding is that customization yields better functional quality versus configuration. That is to say that based on this particular case study, a customer's experience would be better if we write specific code to that customer rather than trying to accommodate them through configurable components. The plugin code as well is also of lower complexity there. And finally, in terms of the third question, the effectiveness of the architecture, our finding is that it is partially successful due to the mixed effects on quality. This then brings me to the end of this particular presentation. Cool.
That's really interesting. So I'd love to know what brought you to study this, specifically in the space that you're in. You come from a project that's been rewritten a couple of times. So did that have some bearing on your decision to go down this path?
So the journey of my master's study was a bit of a long one, and I was interested. It started out with the idea of why don't we have from a software development perspective, a marketplace of higher level components that are well integrated into each other. So in that search for finding something to try and address that question, I had the opportunity of being exposed to a software system that I think aligned well to informing some of that opinion. And it just presented the opportunity to actually study it.
That's really interesting. I see Nazir has left a comment to say that SonarQube is quite helpful. Have you looked at SonarQube at all?
So I haven't personally used it on any of my specific projects. However, I am familiar with what SonarQube does. So yes, absolutely. If you like the Visual Studio Code metrics, you will probably love the SonarQube with all the insight that it can give to you. There are loads of other similar tools, like for example, FXCOP as well in the Visual Studio world. There are lots of platforms out there that can give you the opportunity to evaluate your structural quality.
That's awesome. And I see Evil has said, I wonder if there are any lessons learned that can be applied to better structured teams to deal with challenges that we experienced.
I think it would be hard to say based on this specific study. So for example, there wasn't a particularly large amount of staff turnover on this project. So you've got the same people, working through that source code. But to me, what I would say is that you're probably better off writing tailor-made custom code when it's required rather than trying to accommodate everyone through some kind of toggled feature. So it's not really a team structure thing, but I suppose it would be part of your approach.
Maybe playing to people's strengths and how you structure the team initially before they actually start. But thank you so much for presenting. That is awesome. I'm going to leave the chat open. If you guys have questions, let us know, but that was fantastic. Thank you so much, Jeff. And sure. I look forward to seeing the rest of your writings and publishings very soon. Thank you.
Thank you.
All right. So before we jump into the next section, I have the pleasure of introducing Gimbal. Gimbal, do you want to take over so long and maybe try to share your screen? I'm just going to quickly close my windows. Our neighbors have started making noise again. Sorry.
Okay, awesome. Yeah, share screen is going to be a bit of a challenge. I think I'll wait for Neem to come back and then we'll share my slides. I switched to a new Linux installation recently, and everything was working fine until last night. And this morning, when I tried to share screen, it just goes bonkers.
Isn't that always the way, though?
Yeah, if you can pull up that.
Yeah, happiness.
Okay.
Let me
Awesome.
screen share, and then everyone just let me know if you are able to see. Yeah, well, you can just tell me when I need to move on.
That looks perfect, and I'll just let you know when I'm done. Okay, so
Super.
Amin said that we've got about the rest of the day to do this talk. So what I'm going to do is, instead of my normal usual technical stuff, which dives into code and all that crap that nobody really cares about, I'm going to have a little bit of a high level talk about serverless, which is part of the whole cloud movement, and why it's something that you should look at or avoid at all costs, depending on your scenario. So what I found is that serverless is the easiest way to halve your ops costs or triple it, depending on how you approach things. And there's different outcomes for different folks. I'm going to ignore some of the serverless stuff like databases and all that kind of stuff, because that can get really technical, and it can take a long time to talk through it, and it's very context specific. I want to talk about the more general serverless functions and how that can be something that someone needs to start thinking about when they look at building solutions. And then along the way, we're going to travel through a few things. So if we can go to the About slide. Look at that. Pretty awesome. So if you walk away from this talk knowing that serverless sucks, but you need to support Tia's animal rescue, it's been a success. There we go. Yeah, careful. I put hidden links in there. You can click on stuff and jump around. This talk is also available online if someone wants to follow along on their own machine. It will also remain online afterwards if you want to go back and find some of the links and all that kind of stuff. I know there's going to be a lot of things in here, so feel free to go look it up later as well. And then just thanks to Daryl for giving me the time to tell you a little bit about tiers and all that kind of stuff. And we'll talk a little bit about serverless as well, I think. So let's jump into story time. So at some stage, serverless came around, but it built on a lot of old concepts, right? So in the beginning, we had physical servers, and you can go to the server room and you can kick them around, when they gave you problems and all of that. Then someone got smarter and they brought out virtual machines and blades and all that kind of stuff. And then the cloud happened. And of course, the cloud was the answer to everything because it's the cloud. That's what the cloud people tell us, that it's the answer. And who are we to argue? The cloud evolved and we got stuff like Docker and all kinds of Kubernetes clusters and Elastic this. It just got really, really messy. And actually it became quite a mission to just launch something. And then serverless happened. And all of a sudden, there was this other option where you didn't have all this DevOps overhead that you needed to jump through to be able to actually provide a kind of solution or build a service or deploy something and make it usable to the outside world. What's interesting is that when we think about serverless, the most people that I ask about, hey, serverless, they tell me AWS Lambda. That's the thing that they know about. But serverless started way before Lambda. Back in 2006, there was a company called Zimkey who actually started the whole serverless thing. But there's an interesting backstory about how Canon, the printer and camera people, how they screwed up their entry into the serverless space with, the usual corporate greed and stupidity, and killed a market that they could have dominated. The vision wasn't there and they just dropped it. Google App Engine gave us serverless functionality back in 2008, but their marketing sucked. So nobody knew about it. AWS came along, their Lambdas sucked in the beginning, but their marketing was phenomenal. So people started using it, became more aware of it, and it was just brilliant. So and then based on the success of AWS Lambda, a year or two later, everybody climbed into serverless. Azure, IBM, Google brought out new stuff. Cloudflare climbed in a year or what later. And just this year, IBM also had some more advanced serverless features available, which is pretty interesting if you look at how quickly this has evolved to become something that everybody is talking about and a lot of people are using And it would be nice to kind of understand why and what. So let's go on to promises. So if you listen to the cloud providers, everybody that's selling you this serverless journey, they will tell you that the first thing you need to know is with serverless, you don't have to worry about any hardware or software, configurations, patch levels, security patches. How do you configure the firewalls, operating system updates? None of that is your concern because it's something you never see and you never know about. Scaling is not your problem. So you don't have to go and figure out, oh, how many CPUs do we need? How much RAM do we need? How many instances of which machines do we need? None of that is something you need to worry about either. All of that happens transparently in the background. Software life cycles are not important. So you can do kind of really strange things on serverless where you use bad programming practices to do things. We have lots of static memory allocation, all this kind of stuff, which normally you would not do because it's not efficient in the long run for a machine that's going to be up for weeks or months at a time. But with serverless, because your life cycles are very short, you can get away with, I want to say, dirtier code that still solves the problem. So there's some merit in that. And then, of course, it's cheap, right? You only pay for the time that you're actually executing the serverless function. So instead of paying for all the uptime where you have servers running, especially during business hours where it's a little quieter, and you now have to put in all this effort to figure out how do I scale up and scale down with my server instances. It's serverless, you don't worry about it because you only pay for the time that it's running. Now, that can be a good or a bad thing. We'll look at that a little bit later. And of course, the last thing is that you are super productive because you no longer have this massive DevOps overhead just to deploy a little service somewhere. It is very simple to deploy stuff on serverless and have it running because there is literally almost nothing to do to get it done. So let's look at some of the realities behind this, which comes from more practical experience. The number one thing with serverless is response latency. You can have responses as fast as 50 milliseconds and as slow as 5,000 milliseconds. And it can be anywhere in between, and you have very little control over that. Sure, there's a lot of strategies where you can do static initialization, you can do all kinds of fancy lookup tables and all this kind of stuff. But the reality is that that response latency is something that you cannot control. And in environments where it's important that you have a predictable response latency, that can be a problem. Serverless might not be the solution for you there. In scenarios where it doesn't matter, serverless is perfect because you are saving a fortune just by not running all these Kubernetes clusters and stuff. The other thing that you need to keep in mind with serverless, though, is that it is built and optimized for shorter execution runs. Things that complete quickly, things that don't take too long, things that don't require a lot of processing capacity or time or resources. One thing that I found a little bit of a pain with serverless, especially in the beginning, the tooling is getting better, is debugging. These days, you can run a lot of the serverless functions offline. You can stick through them. So there's a lot of things that have changed, but it's still a little bit of a challenge to debug and also monitor your serverless functions because the life cycles are so short and they run on hardware you don't control. There's a whole bunch of things out there. One thing that gets glossed over, but that I think is getting more and more of a concern, is the security aspect of serverless. You are basically putting everything out into the public space. So all your serverless functions are, for the most part, accessible from outside. So security becomes a little bit more of a concern where you don't have a firewall section that protects you and everything else behind it is protected. Everything's out. So it does change how you think about building solutions. Serverless can also get stupid expensive really quickly. That's because they have changed some things where you can now say, I want a serverless function to be able to run for up to 3 minutes or 5 minutes or something at a time. If you've got 200 of those kicking off and running, you can start running into the realms where it would have been cheaper for you to have actual instances, dedicated instances running all the time, instead of all the serverless stuff that just scales out a little bit beyond your control, it can feel like. Then the other thing, of course, is that because serverless runs, and we'll talk about how it runs a little bit later, runs differently to normal server functions that you might employ. There's some privacy concerns, and it's very difficult to narrow those down because you're not running in any kind of environment that you control. So questions around how private is your data, how secure is it, all that kind of stuff, that's still up in the air. And I know that there's some industries that just don't use serverless because they can't answer those questions perfectly. The other thing is everything in serverless is supposed to be decoupled from each other. So there's a lot of code duplication and tricky optimizations that you have to jump through to be able to do things. And I've seen some horrible things done where serverless functions call serverless functions and all that kind of stuff. It's doable, but it shouldn't be done. But if you're hard set on only using serverless, there are some dirty tricks you have to pull if you want to get things to work. And then the last thing is, funny enough, with serverless, it's very easy to lock yourself in with a particular vendor, and that's dangerous. Cloud is still in its infancy. I don't think cloud is nearly where it's going to be. And a lot of people are finding, especially I find as a contractor, I often get pulled into companies where they have gone down a route with a specific cloud provider, and they have now reached the point where it is ridiculously expensive, and they find that they can't jump cloud providers, or they can't bring different cloud providers in and use the best ones for the best things anymore because they didn't think about that kind of architecture from the beginning. It's not all doom and gloom though. So if we can jump to advantages, I want to tell you a little bit about why this is something you should look at. So the first thing is, if you do it right, you have the freedom to mix and match the best solutions. You don't have to, let's say that your core service is built in .NET, you don't have to build everything in .NET or C#. If there's something that works better in JavaScript or in Python or in Rust or one of those languages, with serverless, it doesn't matter what language you use. There's usually a deployment mechanism for that particular language. So case in point, I did a project a while ago where we moved a company onto a cloud system. And one of the things that they have is a payroll pay slip generator, PDF generator that's written in Python. The entire stack is written in C#, but we kept the whole Python stack to do all the PDF generation because it was already there. So it was simple and easy to throw those in some serverless functions that just get a JSON packet in, generate a PDF, and just allows the PDF to be put onto S3, and there we go. So for them, it made perfect sense to use Python to keep doing what they were doing in Python and not incur the cost of rewriting stuff. Likewise, you can do all kinds of optimizations in the system. I know that a lot of the machine learning stuff, people use R and all that, and you can do custom deployments where you can have serverless do a little bit of data analysis on functions that don't get used often, but have to be available, well, let's say once or twice a week or something like that. So it's a great way to use the right technology to solve the problem. You can save a fortune on things that have unpredictable scalability. So if you have a shopping cart or something like that that gets used randomly through the year and you can't really predict, apart from Black Friday, all of that, you can't really predict your volumes. It's a nice thing to be able to scale out serverlessly, because if you suddenly get an influx from nowhere for some or whatever reason, your servers are not under stress. The serverless stuff will just scale up automatically. And it's transparent to you how that happens. It just happens, and it's not something you have to manage. What I love about it is prototyping, because there is so little overheads involved. I don't have to pull in DevOps people and all that kind of stuff just to do a quick prototype for a particular solution that we are researching. You can throw it in a couple of serverless functions, test it. It might not be as optimized as it could be on a dedicated server, but it's good enough to do some testing, and it's not expensive. So by being able to do cheaper prototyping, you can try 5, 6, 7, or 10 different solutions, find the one that really works, and then put the time in to optimize that one. One of the last things that I want to talk about, of course, is micro deployments. Because serverless, if you do it properly, serverless functions are completely decoupled from everything else. you can redeploy hundreds or thousands of new instances of services throughout the day without disrupting anyone or anything. That is beautiful. So if you have a lot of little calculations and things that happen, especially geospatial stuff, what's so cool about it is you can redeploy fixes on the fly in production without anybody noticing, except they will just suddenly see that, oh, wait a minute, last time I ran this 2 minutes ago, it was the wrong geolat code. Now it's fixed. Awesome. Right? That's the kind of thing I really like about it. And of course, the last thing is, because serverless is always available, but you're not paying for the time that it's just sitting there, you can save a ton of money on things that don't get used a lot. So VAT calculations that run once a month, or stock management systems that do some recon every couple of months, all those kind of things can be serverless functions that you have available for when you want to use it, but you're not paying for it to be available, unlike a lot of the other cloud solutions. Let's jump onto profits. Because, the cloud providers are all doing this to save us money, right? Because that's what they do. They're all out there to save us money and to make things easier for us and to stop ripping us off. But actually, have you thought about serverless and thought about where does it actually run? Because there has to be a server, right? At the end of the day, all that serverless does is it takes the responsibility for managing the server away from you, but it still runs somewhere in the cloud. So a funny story is that if you go look at how these cloud providers operate, you'll notice that most of the money that cloud providers make come from server instances that people pay for, instances that are always running and active and stuff. A lot of those instances, though, are not utilized fully. So we would have a server that's capable of handling our maximum workload, and normally it sits around 60% utilization. Every now and again, it might jump up to 80%, but not really. It's not something that works too hard. Serverless uses that capacity, that provision capacity, to resell that provision capacity to other people. That's why it can be sold so cheap, because it's basically already paid for. So it's a very interesting concept where they are subletting your server space that you've already paid for to other people without cutting in on the deal. I think that's unfair. Let's go to resources. There's one resource, and if you click on this, it's going to go to the serverless.com website. There's one resource that gives you all the information you want to know about all these serverless companies and the functionality that they give. And apart from the big ones, there's little ones. Like Native and OpenWhisk and Spotlinks. There's a couple of smaller serverless companies that I think it would be great if you're thinking about doing stuff serverless to go take a look at what they offer. Because the one thing that we need to watch out for is vendor lock-in. So if you keep in mind that there's all these other companies that provide serverless as well, you can start building your solutions to make use of a hybrid cloud approach. So it's going to save you a lot of money, and it's going to prevent a lot of headache at the end of the day because you're not going to be locked in to a particular vendor. So I will jump into the questions now, the chat. I see. Okay, Canon has killed the market way too often. Yes, they have done some ridiculous things. When I first heard that cloud computing service was, yes, yeah, flagship product at the time was VMs. It just is, and it still is. VMs are killer. Yes, Azure has been quite busy with configuring all kinds of stuff as well. And someone quoted the Diablo reference, awesome. And yeah, people pay and not go, so I can have a lower report. Awesome. Yeah, I see. Are there any questions around serverless?
I haven't seen any come through, but if you guys have questions, let us know. I did want to know, you obviously deal with a lot of the smaller server providers and you've done some interesting serverless work. Can you maybe share with us a little bit about a time when it didn't work out so well and what happened?
I think the biggest lesson that we learned was there was one or two startups that started out with full serverless. Everything is serverless. And in the beginning, it's great because you get like a $30 bill or $40 bill from Amazon. And it's not a lot of money. Then they start to become successful, and you have the situation where, because of the way it was architectured, uh, um, nobody envisioned moving off serverless onto more traditional server models. So now you had these cheap serverless functions running 24 hours a day, 7 days a week, and it becomes ridiculously expensive. So where with the actual instance of a server, you have a finite amount of CPU and RAM available that you pay for. So you have sort of a fixed cost every month. With serverless, Amazon's happy to send you a $50,000 bill at the end of the month. They really don't mind. And we got some guys that went from $30 or $40 a month to $4,000 or $5,000 a month.
Yeah, and on a startup, that's a lot.
That can ruin your month. Yeah.
A little bit. So what would be your advice point to the guys before we get to Gilad's question? So if they are exploring the world of cloud, what would you recommend?
I think serverless is a phenomenal tool to keep in your toolbox, especially when you're starting out, especially when you don't know how things are going to scale, and especially if you don't know whether you're going to have to keep this around or not. So, but I revisit all the serverless functionality that we built. I revisit every 2 to 3 months. Go look at the cost and say, okay, we're running this as serverless. It's costing us $200. We can actually have a full instance running for this and doing 2 other things for cheaper every month at this scale. It might be worth our effort to spend 2 weeks to convert this back into a more traditional API than keeping it maintained as a serverless option. So just being cognitive of the fact that you are burning money, and you have to figure out, am I burning money for the right reasons?
Absolutely. Okay, so Gilad's question, in order to combat the subletting issue you mentioned, do you think the phrasing of the marketing terms regarding performance would change from up to from, like ISPs eventually had to, for download and upload speeds?
So that's an interesting question, and it's actually something that I think most cloud providers have thought of already, and they have this thing where your serverless function can disappear at any moment in time. It's not guaranteed to run or execute or complete. So you might call a serverless function and it will fail 3 or 4 times before it actually starts running and does something. And that's that cold startup time where it can take 3 to 5 seconds before it actually starts running. Because what they're doing is they're saying, okay, we had this running on this particular server, but this server is now getting very, very busy. So we are killing your serverless function because the person that provisioned the server gets priority. And we are now looking for another server that's got idle time that you can throw your function on to execute. And you don't pay for that time, except you pay for it in time by waiting for this to spin up and run. So they've been careful to not upset their key tenants, which are the people that have the provision instances. So I'm not concerned about that, but it is interesting to know that they're making money off space and time and resources that's already been paid for.
Yeah, at the end of the day, it is something to be cognizant about, especially when you've got a new project. So I see Tebogo has mentioned, I thought serverless was the death of traditional models.
I think that is something that they are trying to push very hard because it is infinitely more profitable. But there are realities behind it. The traditional server models can do, especially when you have complex workflows, serverless is a nightmare to manage. So traditional servers will not go away ever, I think. You're always going to have a need for that kind of orchestration of all the workflows. But serverless is definitely a massive add-on that adds advantages, especially in the world where scalability is unpredictable.
Yeah, absolutely. And then Dean asks, what happens on a very busy day when both servered and serverless are at a high?
they just spin up more servers because it's still worth it for them, right? And the thing is, ultimately, if you go look at AWS or Google or IBM, they've got these massive teams of DevOps people that figure out how many million servers do we need to do our workload in every cluster. So there's always machines that are on standby that are up and running and ready to roll. So I don't think that's a problem. But what I'm concerned about though is bandwidth, because serverless creates a lot of traffic. And I've seen at companies where they use a lot of serverless functions, that their internet bandwidth becomes a bottleneck. Because previously you would call a server, send an API request to it, and it would internally do 15 or 20 different calls and then bring a result back to you. Whereas with serverless, it's very often that the client application ends up doing 7 or 8 different serverless calls in succession, which increases the amount of traffic that runs. So I'm not worried about the cloud provider so much, but I've seen offices where they go like, whoa, our internet traffic's doubled over the past month. What happened? Well, yeah. Oops.
But I must say, it's a very different perspective. Thank you so much. I think the fact that you bring it back to the commercial and having that appreciation for how we impact businesses is amazing. Thank you so much. If anyone has extra questions, feel free to leave them in the chat. We will also be responding to them on LinkedIn. But thank you so much, Ewald. It's been delightful having you. Thank you, Jeff, for putting together your sessions. And I will be releasing the sessions very soon. I think that's it for us for today.
Awesome.
Otherwise, I'll see you guys very shortly and have a fantastic week and almost weekend. All right.
Thanks,
Bye
everyone.
for now, everyone.
Ciao.
Thank you very much. Goodbye.